All right, in this video, I'm going to show you how to solve a system like this that's not two lines. So this equation here represents a parabola, so you'd have a shape like that, and this represents a line, so you'd have a shape like that, and we want to try to find the ordered pairs where it intersects, where the line crosses the parabola. So I would use substitution in this situation. If y is equal to this, then I would replace that y with that equation. So then you would have 3x minus this function, x squared minus x minus 1 equals 4. And make sure when you have your minus on the outside of your letter that you think about the fact that that minus is going to go with the whole equation. So you would have 3x minus x squared plus x plus 1 equals 4. Then I would set it equal to 0 and combine like terms. Because this is negative, I'm going to move it over to the other side. I like my term on my x squared to be positive. So I'm going to have 0 here, and so I'm going to move that over. That's going to be a positive x squared. I have a 3x and a 1x, that's 4x. So when I move it over, it's negative 4x, and then I subtract 1 from both sides. I have a plus 3. Now I can factor this into x minus 3 and x minus 1, giving me x equals 3 and x equals 1 as my two x values. So I know that this is going to happen at 1 something, and this is going to happen at 3 something. To figure out the y values, you've got to go plug it back up into one of your original equations. It doesn't matter which one. So if I plug it into y equals x squared, if I start with my 3, that would be 9 minus 3 minus 1. So 9 minus 4 is 5. So the 3 gave me the 5. If I plug in 1, then y is equal to 1 minus 1 minus 1. So that would be negative 1. So this happens at 1, negative 1. So you may very well have two ordered pairs on some of these equations. Now you could also have no solution. You know, you could have a parabola and a line like that that never cross, and if that's the case, when you go to solve, you're going to get you'll get something that doesn't factor, and you'll get a negative inside the square root when you try to do quadratic formula. Okay, so you do that one with substitution. Some of them, though, you can do with elimination, which is not, I prefer elimination, so I like that. So let's say you have 4x squared plus 3y squared is equal to 48, and 3x squared plus 2y squared is equal to 35. So I need to get my x squares or my y squares to cancel out. So I could multiply this top equation by a negative 2 and the bottom equation by 3. That would give me a negative 6y squared and a positive 6y squared. So, by the way, these two things look kind of like circles. If you remember, x squared plus y squared equals a number is going to be a circle. So when you have numbers on the front of the x squared and y squared that are not the same, you have an ellipse. So we have two ellipses here, and we're trying to find where they intersect. So if I multiply this by negative 2, that gives me negative 8x squared minus 6y squared equals negative 96. And if I multiply this by 3, then I get 9x squared plus 6y squared equals 105. So that's going to cancel out. Then I have 9x squared and negative 8x squared, so that's 1x squared equals, and 105 minus 96 would be 9. So x equals plus and minus 3. Don't forget that it could be negative, so I've got plus and minus 3. Now I've got to plug that back into one of these equations to solve for my y value. And it doesn't matter which one, I'm going to pick the one with the smaller numbers. So 3 times x squared, so 3 times 9, plus 2y squared is equal to 35. So 27 plus 2y squared is equal to 35. Subtract 27 from both sides, and you get 2y squared is equal to 8. So y squared is equal to 4. Therefore, y is equal to plus and minus 2. So you have two possibilities for the x and two possibilities for the y, and they both go together, meaning it's not like the positive 3 gave me a 2 and the negative 3 gave me negative 2. I could plug a plus or a negative 3 in here for x and I would get a 9. I could plug a plus or minus 2 in here for y and I'd still get 4 for y squared. So I can interchange these. So that means I'm going to have 4 possibilities. I'm going to have both positive, so 3, 2. I'm going to have both negative, so negative 3, negative 2. And I'm going to have one of each. Negative 3, positive 2, positive 3, negative 2. So those are my 4 different answers for this. So if you want to see what this looks like, you can graph both of those on Desmos and see where they intersect, and you'll see what's going on. Okay, let's do one that does not have a solution. I'll show you what that ends up looking like. So you have 4x squared plus 9y squared equals 36, and then x squared minus y squared equals 25. So at first glance, it looks just like the problem we just did with some simpler numbers, and you'd think that it should work. So let's multiply this by a negative 4 and get my x's to cancel out. So this one stays 4x squared plus 9y squared equals 36, and then this will be a negative 4x squared plus 4y squared equals a negative 100. Okay, so far so good. You get your x's to cancel out, add that together, you get 13y squared, and then negative 100 plus 36 would be a negative 64. And so that's not, I can tell right there it's not going to work. When I divide by 13, you know, this is going to be some decimal, but it's negative. A positive 13 times y squared is never going to give me a negative number. So you can divide by 13, you're still going to get a negative number there, and you cannot do that. You get an imaginary solution. So, no solution. That just means these two graphs do not cross. So one of them is an ellipse. This one would be a hyperbola. It's something that looks kind of like that. So probably what's going on is you have an ellipse in the middle. You know, the hyperbola will go on forever, and you have an ellipse and it doesn't cross. If there would have been a solution, it would have been something like this, where the ellipse crosses and you'd have 1, 2, 3, 4 solutions. Okay? So again, if you want to see what these graphs actually look like, you can type them both into Desmos and take a look. But no solution means that they do not cross anywhere, and you know that it's no solution because you end up getting something that is impossible to solve.